This is the Amp Hour Podcast. Recorded January 6th, 2016. Episode 281. Crossovers and call-ins. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
I'm Alicia White of Embedded FM.
And I'm Chris White, also of Embedded.fm.
And this is a crossover episode.
Dun dun dun.
I was going to say cue the music. Yeah, you did that.
This is like where the Fonz shows up on Alf and they all go to Gilligan's Island, right?
Wait, that one, someone had posted about it was Dave Vandenbout had posted about those. I didn't know are there really that many crossover episodes? I've seen some.
They were big in the late 70s and the early 80s.
Yeah.
It was when you ran out of ideas completely.
Yeah, right. Right before you jump over the shark, right. you do a bunch of crossover episodes. So that's coming, folks.
I'm so looking forward to them jumping over the shark.
I think we're the ones jumping.
Oh.
Yeah.
Whoops.
We're all jumpers at some point. So how are things going? I haven't listened to your episode this week, but I'll do that tomorrow.
Well, it's only been up for a few hours, so I wouldn't expect you to get to it immediately.
I don't know. I've already gotten responses on some of the questions I asked. It's great.
Awesome.
This one is just
Internet power.
Me and Christopher talking to each other about random things. We talked about things you can put into your ear.
Okay. Like Q-tips?
It was high technology.
Yeah, that's right. Highbrow. Q-tips at 30,000 feet. Cleaning your ears in a airplane. That's great. I can't wait to listen to that. If people haven't noticed, we are noticeably Aussie-less, but we will have at least, God, how many?
3.
Like 2 or 3? 3? Yeah, 3 Aussies who will be calling in. And of course, I mean calling in by, we'll call them on Skype, and through the magic of editing, it won't sound like it.
Don't call us, we'll call you.
Right, exactly. Yeah. So what are we expecting here? Are we expecting more embedded, or are we expecting more non-embedded? I'm wondering if I'm going to be sitting here like, I don't know that. Ask those two.
I was sort of expecting car talk, where they ask us technical questions and then we ask them about their relationships.
Oh, I like that. Actually, another one too. I don't know. I was listening to a recent, not so recent episode, and the trick I love is when they're stumped, they say, "What color is the car?"
That's a very good question.
Yeah, exactly. It's like, oh, you're having trouble with your oscilloscope? What color probe are you using?
Yeah. What do you have this persistence set to?
Yeah. Yeah, so all the usual stall tactics, right?
I think since you did inform people that it would be us, that we're going to get a few more software questions than normal. But if it goes too far software-wise, I have a couple electrical questions outstanding.
You do? Oh, good. Are you still... Is this the mice thing, or is there other new things?
We're way past that.
Oh, yeah, mice are gone. Yeah. BB-8, something. No, that's gone too.
BB-8's still around. I've been playing with those little tiny quadcopters, the Cheerson CX-10s that are just over the size of a quarter. Mm-hmm. And they have some really neat feedback control of their DC motors. That's
right. You did send me a sketch, and I tried in vain to guess what was going on there, and then it was quickly rectified. But yeah, it's neat. It was using a little STM32, or what was on there?
Yeah, an STM32 F0 line, their Cortex M0 line.
Oh yeah, that's what I use for Contextual Electronics, actually.
The way that they're doing feedback is sort of cool, but let's see if we get time for it. If we don't, then I'll put up my best guess in sketch format, and you can all the electrical engineers can tell me just how wrong I am.
If you hear gurgling noises followed by us dropping off, that's because we've drowned.
Yeah, there's a bit of a storm.
Oh yeah. Right. In your new abode, people don't know Chris and Alicia moved to a place by the water, right? You're
More water than we had
Beach
anticipated.
Right. Well, yeah, especially now. Yeah. We should probably so if someone hasn't listened to Embedded.fm before and they haven't heard when you guys were on the show before, which was 255 or 256.
56.
Can you give the quick rundown of Embedded.fm?
Sure. Embedded FM is the show for people who love gadgets. You can tell I've said that a few too many times. But it is somewhat the companion show to the Amp Hour that we focus a little more on the software side of embedded systems. And we focus somewhat more on the engineering as a whole. We talk more to educators and people just really enthusiastic about how technology goes in their lives. Although we do have a few shows that get pretty deep into technology, like keywords in C and processors and
Kalman filters.
Kalman filters.
Oh, yeah. Yeah, I remember that one.
So yeah, if you are on the software side, you should come try us out too. If you're on the EE side, you should only come because you want to laugh at us when we try to puzzle out, say, motor circuits.
No, it's good. No, it's important to have that kind of that crossover knowledge, right? Even I think a lot of people that listen to the Amp Hour too are interested in electronics and might be coming into it, and I think that's really important that electronics people move into the firmware side too. I mean, I've been talking to people recently. It's like, name a project where you don't have, a micro on it these days. I feel like there's always you can always have some of those, but it's just such a draw to have a small micro on there, like that STM32 chip or something.
It gives you such flexibility, and now that they cost like dimes.
Dimes?
Yeah, I mean, you can get that one for like a quarter. And there are lots of other processors you can get for like under 10 cents. It's just incredible. I mean, we're talking consumer grade when you're ordering hundreds of thousands of them, but
Oh, yeah, okay. That's why I was confused. I was like, I'm not paying a 10, 25 cents.
No. You have to order a few more and not get them on the dev board.
Right, of course. Yeah. Yeah, they always sneak the better ones on there. Oh, well. Yeah, no, that's a good point, though. And, I mean, it's not like, especially when you already have 32 bits there, it's not like there's going to be an upsize in the future, too. So it's, it's relatively stable on a lot of fronts, and there's a lot of cool things you could do, and
power efficient,
like field updatable.
Yeah.
Well, and everything's becoming so much more modular. You can build things with, micro and a couple of I2C devices, and just not that much electronics going on there. So it's it's a strange new world.
Did you guys see that new Seed Studio, the YO thing?
No,
it's like it's another ESP 8266, but then they use the Grove. Yeah. But the crazy thing is like the app that they have with it. So it's a little that hooks up to an app, and then, because they're using a lot of their other modules and they have a pretty big library, it's just like tap and go kind of thing in terms of getting all the pins connected in the software, and then you're just writing Python again. And so that's kind of the promise of like the IoT thing, but also I'm sure that there's other layers in there, but for getting started, it's pretty great.
Yeah, hopefully it doesn't take off before I retire.
It might, but I don't know. Like I don't think you have both made your money on like people using apps to hook things together and write Python, right?
No, but if it gets too easy, it's just not worth it anymore.
Yeah. Well, true. Yeah. But then you can manage people while they
no
tap apps.
We've done that.
Been there, done that.
I know. Super fun. I'm always hoping people will need lower power, so I can always optimize and get rid of all of the fluff on top, and Python and interpreters and RTOSes.
Yep. Yeah.
The other 24 bits, so you have an 8-bit processor in there.
Well, the money's always in the corner cases, right? So that's where I think you guys will do okay. So we should kick in to start listening to questions and pretending we know what we're talking about, huh?
Sure. So our first guest, I wanted to make sure that people didn't miss the Aussie accent. So I have Steve Dalton as the first guest. Do you want to get him on the line?
Sure thing. Hello, Steve.
Hey, Steve.
Hello.
Where are you calling from?
I'm calling from the sunny Gold Coast in Australia.
That's the top part, is that right? Sorry.
It's the bottom of the top part, if that makes any sense.
The bottom. Okay. Yeah. Cool.
Yeah, it's pretty nice here at the moment. Looking out on my swimming pool.
So, what are you working on? What do you got a question about?
Yeah, well, my question is actually around. It's not a technical one, but it's a bit of a pet topic for me because I help run a hackerspace here in Australia. I know a lot of hackerspace members that have kind of made this leap into the pro maker world, for want of a better word. But yeah, one of the things I've seen is a fair bit of negativity from people in traditional electronics, embedded software industry towards us. All the usual arguments: we're hackers, we don't care about testing, industry standards, regulations, which is kind of partially true. But also crazy things like, you don't use Altium, so you can't be any good, or you haven't been trained to use the equipment properly. And on the flip side, we see people who just kind of see us as magicians. They can whip up anything in a week. So really my question for you guys is, what do you think of pro makers? And do you think there's an intersection between pro makers and mainstream industry?
Well,
first, let's get an idea of what you mean by pro maker. I mean, I have some idea, but you probably have a specific idea.
Yeah, so I guess one definition might be, people that are making things to sell to other makers. But what I'm talking about more is people who've kind of, they may not have a traditional electronics engineering background, but they've learned a lot of skills in hackerspaces, and then they've seen problems out there and then tried to build a business around it. So people who are making a business out of basically using their maker skills.
There's actually a book called Maker Pro that is about the people you were talking about, the folks who
that was David Lang, is that right?
It was a series. I mean, it was a bunch of essays from different people.
Oh, okay. Oh, I remember that one. That's right. Yeah.
Sophie Kravitz contributed to it.
Yeah. I think though the term maker is pretty loaded these days.
Yeah.
But I mean, at the end of the day, it's really people starting businesses, and it's just that they start to edge into people's, expertise areas, and then they get a little uncomfortable about that. Oh, you're not doing it this way, you're not doing it that way. But I think what ultimately, so we were just talking about the dropping cost of, not the dropping cost, the rock bottom prices of micros. What that enables you to do a ton of stuff. You could throw a micro at a problem that you could have done with a couple transistors or a 74 series logic chip or something, and yes, those are all ways to do it, but sometimes the way that's fastest is going to be and most accessible is going to be the one that gets it done. And then you hire people like Chris and Alicia to make it like super huge for, if you wanted to go to full production type thing, right?
Yeah, I have mixed feelings about it, Steve, because, people do have new things that they come up with and come with different perspectives. So somebody from a hacking or a making background, they may have ways of doing things that traditionalists really haven't thought of. On the other hand, there's reasons for the traditional solutions being the traditional solutions. I mean, you mentioned testing protocols and things, and that's going to be the difference sometimes between a business succeeding and failing, or moving beyond 5 and 10 units to 100,000 units, because
we're getting sued.
Yeah, because you can't afford to make mistakes at those levels, and so I can see some of the pushback there having some merit. On the other hand, there's probably a lot of it that's sort of cliquism and protectionism, where it's, I don't want people without a traditional education. That doesn't seem fair. That I went to school for 18 years and you're just making something and look how well you're doing. I bet there's a little bit of that.
I can see both sides. I feel like I've been both.
Yeah.
I mean, I've definitely been a very traditional engineer, college, and then HP, and then FAA and FDA certified products. So I've definitely gone through the process of making a solid, super solid, robust system, even to the point where mistakes would cost thousands or hundreds of thousands of dollars. And while that didn't come out of my salary, I felt very responsible for them. But then lately, I've had a lot of projects where it's just build us a prototype. And I'm not enough of an electrical engineer to be able to do more than go to Adafruit or SparkFun or whatever and pull all these modules down and hook them together and then sort of feel out where I need capacitors and resistors. So in that case, I feel like I am being one of those maker pro people where I'm doing the making thing and I'm doing it professionally, but I admit that I'm only making a prototype, and if you want to go to production with this, I want you to find a nice EE who can vet this system.
Well, we all do that too with software too. I mean, if we're doing something quick and dirty, we all feel the things we're doing wrong as we do it.
Yeah.
Sometimes we're ignorant of it. Let's be honest.
Yeah.
I speak from my own experience. I think another thing that Alicia kind of brings up there though too is just the concept of ego, right? I mean, so if someone comes in and they're like, "Well, I know how to do this. I did this with an Arduino." That's a lot different than like, "Well, I made this thing," like Alicia's doing. "I made this thing. Let's talk about the realities. If you want to make a lot of them, this is, we should probably talk to other people." And it could be where some people have experienced that tension between, traditional and maker pro type people, but I think it goes both the ways, because I've known some crotchety old people who are traditionalists for the sake of being traditionalists and don't even try new things, and that's like, whatever. You're gonna okay, enjoy,
Well, I think it was actually Neil Peart who said that the difference between an amateur and a professional is that an amateur stops when it works once, and a professional stops when it never fails.
I can't believe you know a Neil Peart quote that I don't.
I didn't get the words right, but
the drummer.
Yes,
like
he writes really good books. Okay.
Yeah. So, Steve, what do you think? I mean, is that close to what you were thinking or no? He's not even there.
I think we'll call that a win then.
Yes, all right. An amateur hooked up this show.
So blown away by our answer that he just had no words left.
He did awareness his
Steve,
network.
welcome back.
Yeah, that's all right. Aussie Broadband. Ask Dave about it.
Yeah. How much did you hear? Did you hear what we were talking about?
I got most of that. Yeah, I just had a comment.
Okay.
So yeah, I had a traditional electronic engineering background, and I did a graduate training scheme. I worked for 3Com in the UK, before they went belly up, and I really appreciate that time that I had, and I got to do things, and be taught things in a certain way, but. Those opportunities don't exist anymore for a lot of people, especially here in Australia. We don't have the big companies that do that. So I've had a lot of fun just in the maker world, making things, and a lot of the things are one-offs or they're prototypes, but actually building things very quickly and actually getting, some immediate feedback, which I never got in that, the big company world. So I think there's a lot of satisfaction you can get from that. That you sometimes miss out in the big world, big bad world.
Yeah, the dopamine squirt of, hey, I made a thing.
Totally agree with that. Yeah, the first 6 weeks at startups have always been the best part of
that's so fun.
my career. And I think
we've got a ping pong table and a shitload of ideas.
That's right, and a prototype that barely works.
Yeah, right. If you just touch it this way, it works, but if you touch it that way, it doesn't.
One of the best things One of the best things we ever built was built in under a week, and it was a one-off for a trade show. And it was a giant Monopoly board that controlled this huge screen. It was for a tourism and trade show, and it was literally a single Arduino inside with some Ethernet cables, and we made the buttons on our laser cutter, and we did it in less than a week.
Nice.
And it only worked. It was only needed once. It had to last 2 days. And then it was all ripped apart. But it was like one of the best things ever, because the screen it controlled was like massive, and it got on the TV because it was like the best thing at the show. Nice. They actually did a little thing standing in front of it, pressing the buttons. So it was very simple, but awesome.
That's great. And
cool.
And what is the name of your program again? The one you work on?
Sorry, what's that? Sorry, the company.
What's the name of the program you work on that works with the Maker Pro type folks?
Yeah, so Gold Coast Tech Space, which is a hackerspace on the Gold Coast. But we do all sorts of bits and pieces. We do a lot of stuff with kids and educating kids and moms and all sorts of stuff. So it's been fun.
Very cool. And we should also point out that Steve is not a plant, but he has been on the Embedded before. What episode was it?
It was 69. I believe it was Dingo Rabbit death match. 63.
63.
And yeah, he
That's
told
so
us a lot
funny.
more about the Gold Coast tech space, which was pretty cool.
You can go back and listen
Yeah.
to that one.
That's great.
Cool. Thanks,
Yeah.
guys.
Thanks for calling in,
Thanks.
man.
Thanks, Steve.
Thanks a lot. Cheers.
Well, I'm glad we were able to get him back. We just like went the rest of the show and we're like, oh yeah, we were gonna talk to people.
We didn't actually have to answer the questions, right? That wasn't ever the
No.
goal here,
Oh.
was it?
Come on. It is technically the amp hour, right? I mean, this is so we don't deal with answers too often. Who's up next?
Lee Wiggins. It's another Aussie.
Another
I
one.
know.
Man, everywhere.
Yes.
But mostly Australia.
That's right.
Although
Okay.
I do sort of fear that we should have had Lee talk to Steve instead of to us, because it seems like his question may be. Well, let's get him on the line and find out what his question really is.
We can always call.
We can always answer a different question.
Yeah.
This is like car talk. We'll ask him about their relationship if we don't like their question. Okay, what you do is you wait for him to answer, and then you say, "Hi, I'd like to order a pizza."
G'day, Chris.
Hi, I'd like to order a pizza. Is that
Sorry, mate, fresh out.
delivery time would take too long, anyways. Welcome, Lee. Where are you calling from?
Yeah, thanks, mate. Yeah, Lithgow, New South Wales, just near the Blue Mountains. How's the audio? Is it all right?
Yeah.
Yeah,
You got an accent coming
Yeah.
through there.
Yeah, that's good.
yeah. It's kind of heavy. I gotta say.
Yeah, I know. Sorry, can't help that. comes with the trade.
Yeah. So, Lee, what kind of
How's it all going?
good? What kind of work do you do?
I'm a power line designer for Endeavour Energy. So, yeah, designing overhead systems, 11 kV, 22 kV, underground, anything that sort of comes my way. It's, doing a lot of steel mains replacement at the moment. So it's a lot of rural stuff. It's been
He's
good.
saying KV, right? Like kilovolts, like
Yes.
kill in kilovolts.
Thousand.
Yes.
Yeah.
I hope he's got an electrical question, because there's
Yeah.
no way.
That's not that bad.
Well, here's what I'm thinking. He's alive and he's talking to us, so he's pretty good at what he does.
He didn't say how long he's been doing it.
Well, yeah, haven't been got yet. I'd like to keep it that way too. You don't get many second chances.
Yeah, man, that's nutty.
Yeah, the high voltage. We've got a low voltage rescue kit that we use that we have to put out near the poles when we're working low voltage live. But the high voltage rescue kit's a dustpan and brush, so that doesn't fill me with confidence.
And low voltage
What
is
is-
what?
600 volts, right?
Yeah, 240 to 415, three phase,
Jeez.
just street stuff.
Yeah, just the boring, the ticklers, you know.
Yeah. Gives you a mustache at night time, that sort of stuff.
Yeah, that sounds right. So, Lee, what kind of questions do you have?
Well, I've been doing, obviously power's my thing. I've got advanced diploma in electrical engineering and doing my degree, but I'm currently doing the degree and full-time and kids and family and all of that sort of stuff. So, I mean, it's mainly concentrated around power, but I love to do electronics as a hobby and have been doing it for a while. And a mate of mine, Toby, up the mountains, actually put me onto Arduino quite some time ago and have been doing a few projects ever since. And recently I put up a dummy load, which has been really successful on Instructables, and it's got 60-odd thousand views now, and Dave did a really good review of the PCB, which I was really happy with. And it's just starting to, go into the world of all the projects that I'm doing is starting to get a little bit beyond the Arduino processors as such, not so much the IDE, but the processors that they've got. And I just wondered when the right time is to step out of the Arduino world and where to jump to from there.
Ooh, I have so many suggestions on this.
I have one.
Well, you go first then.
No, it's I don't actually have one.
So, Arduino is great, and
Yep.
you said you're okay with the IDE, right?
Yeah, like I've actually got a web development business that I run as well. So I mean, coding in IDE and that side of the software side of things is not really a big issue for me as such.
Okay, some people hate the IDE, and they
Yep.
can remove the IDE and go to GCC and have a good time with an 8-bit processor because the Arduino is so ubiquitous, has so many things it can play with. But if you like the IDE, okay, but are looking for a processor that can do more underneath there, you have a ton of options. The first one I would recommend would be the Mbed system. That's from ARM, and so it's all the Cortex processors. Cortex M0s with their little low power, or the Cortex M4Fs with their floating point and higher capabilities. And it's still online. It's still free. And it still has somewhat dubious debugging ability, which is one of the downsides of the Arduino IDE.
Do you hate debugging? We have a platform for you.
Yeah, debugging on Arduino sucks. Yeah, debugging, yes, it really is a nightmare. I have had a bit of a look at the ARM processors, but to be honest, it took exactly where to start and the IDEs for developing them and physically how to program them. You know, I was finding it hard to get some information on, because Arduino, there's so many great tutorials out there and there's so many marvelous things. And I've seen the F4 discovery boards, but it's even, you know, there's so many, I guess, tutorials on how to get started, but it's certainly not an easy thing. And I'm not so much concerned about me, but more of the people that are working with the projects that I develop, you know, being open source stuff. And I want it to be easy and doable for them as well.
And that's really why I say Mbed, because it is free, it's online, so you're not worried about other people's operating systems. A lot of people are using it as the next step beyond Arduino. As for programming it, all of the boards that are marked Mbed Ready or mbed.org or have an Mbed in the name, they plug into your computer and act as a thumb drive. And so to program them, you simply compile, and sometimes you drag it over to the thumb drive, and sometimes your browser will do that for you. But it's sort of like the Arduino, that you don't even really notice that it's putting code down there.
Yeah, okay.
And that
very good.
It's really easy to use, and like the Arduino, there are a ton of other people doing this, and it's mostly open source.
There's a lot of libraries out there for various types of peripherals and things, and you know, they're more powerful than Arduino, so you can do things like, you know, Wi-Fi and networking, full networking stacks and things on the chip.
So when it comes to, you know, programming the devices outside of the discovery boards and outside of the development platforms that they're in, say I just wanted to grab an ARM processor, let's say I picked an M4 that was, you know, suitable and to the needs, and I wanted to put that in my project. How do I then program that? Is it something that you, like, you know, obviously I've got the ICSP with Atmel that I've been using, but is it similar for ARM?
Yes. There are a number of different programmers, and they cost between $15 and $70. And if you get a dev board, I mean, some of them cost a lot more than that, but realistically, the home ones are 70-ish. If you get a dev board, that's usually part of the board.
Yeah, okay.
And sometimes you can even break that off and use that on other boards.
Yeah, I'm doing that right now. I have, for a client project, I have a dev board for a completely different chip, and I use that as the programmer for something else.
Yeah, right. Yeah, very good. Yeah, okay, so it's not such a big step.
It's not such a big step if you take the right step. If you try to go directly to, you know, standard production methods and pick a chip and build a board and pick flash to go with it and then buy an IDE, that, you know, that's way out there and much more complicated, but you don't need to go there.
Yep.
Just yet.
What is the end result of what you're, so this is still going to be kind of hobby style projects, or do you want to actually kind of maybe get towards making a device and deploy stuff into production like that?
Well, at the moment I've got my dummy load that I've been working on, and I'm sort of up to Rev C at the moment, and I'm hoping to do a Kickstarter on that and do some improvements. And the Rev B one's been very successful. I've been selling just the PCBs, and a lot of people have been buying them and building the kits, and a lot of people have, you know, been posting that on the Instructables, which is awesome, which is what I love to see. But yes, ultimately I think I would like to go, you know, not go into business and, you know, give Agilent a run for their money, but I would like to just, you know, create this sort of stuff. And the next step, you know, I'd probably keep my dummy load with Arduino because that's where it started. But my next step is to try and, you know, build a power supply, something similar to the Rigol. Is it 832? Something similar to that. but make it open source and hobby level and, affordable for a lot of people.
Well, I'd say don't underestimate the ability for your customers to tinker and create community around it too, because that'll have a lot of benefits just from like, oh, hey, if you wanted to do this other thing or have this improvement, that can have a lot of benefits where if you close it off and, do a traditional like, oh, well, there's one firmware version and you can update it, that makes it a little bit tougher.
Yeah. Yeah, that's true.
I think Mbed is still in that same family where it's like if you can plug in and then maybe even easier, because then it's just like the board plugs in, you drop a new file into this file system like Alicia was talking about, and then it possibly is even easier because you don't even install the Arduino IDE then. So
yeah, true. That's true. But it's something that I certainly want to keep open source and certainly want to keep hobby level. And the code for my dummy load's been on GitHub for ages, and I've had 3 or 4 or even 5 actual commits that people have worked on and improved, and I really like that, and I would like to keep that going. So I'm glad to hear that a lot of people are on the Mbed system and going for the ARM type processor, and that it's not going to be a big jump for a lot of people. That's really reassuring.
Yeah. The only other step that the one thing that I was going to suggest, of course, was we made the same decision in Contextual Electronics, and ultimately we said, well, we didn't want to go all the way to like what Chris was talking about, where you're buying a full IDE, like usually like a Kyle or something like that, and you're buying, this really good software.
Yep.
So we actually kind of struggled through the Eclipse and then using the ARM tool chain and stuff like that, and Open GDB and stuff like, or whatever that's called.
Open
OCD, Alicia? OCD, thank you.
Yeah.
So, like that is a struggle, but then that's to get to the troubleshooting level of side of things. So
yeah, right. The other thing I've been looking at a little bit lately, just out of interest rather than anything else, is DSPs and sort of where they sit in the grand scheme of things, and whether I should be running my displays with a DSP or whether I should be doing it with an ARM level processor, or from my very limited understanding of DSPs, is that more sort of used in audio and video world of file conversion from audio to digital, and not necessarily for driving displays. But do they sit in that sort of world? Should that be something I'd be considering to run a display with?
No. I don't think so.
I wouldn't either. Yeah, no.
DSPs are neat. DSPs are really, really cool, but don't
Crunching
use
numbers.
them for what you. You're better off using an ARM for its general purposeness. And some of the ARM controllers have LCD controllers as part of them.
Yeah. Okay.
So look for that.
Good. Yeah. Nice.
Or use SPI based and you can just use one of the ports, and like there's really a lot of options there. I would
SPI
be
based
hard pressed to
displays,
find one that's
you can
DSP.
do a lot with a SPI display.
Oh yeah.
Yeah, well, I love SPI, and I've been playing with a 2.8-inch TFT at the moment on SPI, and I've just put it onto Parallel actually, and on the the 16 megahertz that I'm using, it's just slow, but and I guess I'm not sure of the maximum SPI speed that I can use on this particular one, but I may be able to improve it, but. Yeah, just the speed and the flash size and the peripherals and the USB and the LCD peripherals is the main reason for sort of getting away from, not the ARM, the what are they called? The Mega type chips and Arduino style. That's smaller 16 megahertz type processors, the 8-bit processors up to the 32.
We talk about the Arduino as though it's a really functional thing, and it is for a small number of projects. But when you look at a Cortex M0, the very bottom of the Cortex M0s, the very top of the Atmega chips, they don't overlap. I mean, you get a lot more in
There's
the
a
Cortex
jump.
M0.
Yep.
Yeah, and if you go to an M4, you've got floating point and DSP and a bunch of other
160
stuff.
megahertz.
Yeah.
Yeah.
And the
Nutty.
chips by themselves, the Cortex M0s are cheaper than the Atmegas.
Yeah.
For
and
the
that's I
Arduino
just can't
Atmegas.
get past. That was another reason I just couldn't get past, why I haven't done this, and that's another reason that's sort of been pushing me to go that way of having a very quick look, and I guess configuring the USB interface and all of that stuff myself is a little bit, I guess, daunting to start with, because it's just so easy. You push a button and it's there, but a lot of the setting the registers and a lot of that sort of information, there's a lot of information out there to read on that, I guess.
Well, for the embed boards initially, it should be just as simple as Arduino. I mean, you shouldn't have to do anything with the USB. It just pulls down, and
Just
suddenly you have a new thumb drive. Yeah, it's kind of magical.
Yeah, cool.
Cool. Well, Lee, thanks for calling in, man.
No, that's cool. Thank you very much for the opportunity. And yeah, it was really good to talk to you both, and all three of you. And shame Dave's having a bit of a lazy attack and on vacation, but we can't have it all.
Can't stop Aussies from taking vacations. That's what I've learned. It's it's a
too
birthright.
Too right.
I was wondering about his vacation, and then I realized that it's the other season there. It's not dark and cold where he is.
It's the good season there.
Yeah.
Yep.
Actually, we've probably just had about nearly 150 mil of rain nearby. So, yeah, a lot of people need it. All right. Well, thank you very much.
Well, thanks again, Lee. We'll talk to you soon.
Thank you.
Thanks.
Okay, the next person on my list is Stuart McAndrew. He is another Aussie.
What is
I have to
happening?
wondering what is going on with this list. And I have to warn you that Stuart and I got in a battle on Twitter. Who could come up with the worst ocean puns? And I gave in. I mean, I ceded the battle to him.
Uh-huh.
But I just want to warn you before you call him that whatever happens here is probably my fault.
Okay. Now I'm going to try and think about one of my own. I have to get on pun battles. All right, here we go. Hello. Hey, Stuart. How are you doing?
Hi. Good.
Greetings.
Hi, Stuart.
Yes, hello.
So where are you calling from?
I'm calling from Perth, Western Australia, a long way from nowhere.
Oh, the left side.
Yeah, that's it, yeah.
Wow. That's different than most Aussies that we talk to. And you're the third Aussie in line. Did anyone tell you you're going to be the third Aussie in line here?
I did, and I think there's more to come.
Oh, seriously? Oh, jeez.
It's
All right.
It's a
Clearly
great calling
stacked the
time.
deck here.
It's right in the middle of their day.
Dave's not here, is he? No, that's good.
So I heard that you and Alicia were having ocean puns. Is that right?
Yeah. I think Chris started it.
Me?
So,
Other Chris.
Oh,
Other Chris.
that doesn't.
Other Chris.
Oh, okay, that's right.
Yeah.
No, it was you, Stony Monster, Chris.
I did.
Yeah.
Yeah.
Had to do with a dolphin picture.
Oh
Well, maybe I started the pun.
no, I started it.
so what was the best one then?
I don't know if there's best when it comes to puns.
Yeah, you can't grade them like that, Chris.
Okay. What was the worst?
I think it was when I finally admitted that I was done and I couldn't go on and then Stuart
prawn one.
Well, okay, maybe I did the prawn one, yes. But then Stuart said he didn't harbor any ill will, so it had gotten to that point.
Okay. All right. Yeah. That's usually where the ship runs aground.
Okay.
All right. So Stuart, what is your question for us?
So I just wanted, it was just a sort of a general sort of discussion point as talking about watchdogs, which is better, Beagle or Alsatian? And sorry, I had to slip in the puns. No, external versus internal, sort of the pros and cons of each type, and I guess which one should be used in each situation.
Well, internal is cheaper because it comes with your processor. External is a nice fail-safe.
The external is a separate chip. Is that what we're talking about there?
Yeah, that's right. A lot of them are coupled with voltage supervisors. So,
Okay. I've used one of those.
And those are nice because it doesn't depend on anything you're doing in the processor. Your software can't disable it. It happens whether you like it or not. So if you have a safety critical system that you don't want any dependence on software for like FAA or FDA or space systems, an external one has some good advantages. You really, it's gonna happen.
How do you keep that alive then? You just pull down on a pin every couple,
Exactly.
every 10 microseconds or something?
Yes.
Okay.
The downside, of course, is if you don't want it to work, then you have to.
If you want to update your firmware and you need a whole second to do it instead of the 3/4 of a second it gives you, then
Do
you're.
they have disables on the chip or no?
yeah, most of them don't have. They're pretty. The timers aren't very long. There's some do have a multi-second sort of interval, but a lot of them seem to be fairly short.
Yeah.
Where I can't imagine So what are the reasons to not use internal again? Because that's usually, I mean, that's the ones I've seen. And, you always see, like, you always disable them when you start debugging, that kind of thing. Because if you hit a breakpoint, you're like, no.
Right. Well, that's the very reason is they can be disabled. So if you're going through a safety critical product, it could be argued that, well, what happens if your software screws up and disables the watchdog and then something goes wrong and you don't catch it? Or you write a bug that disables it and you forget to re-enable it. With an external, you don't have any choice.
Right.
Anything that happens with your processor is being managed from a different place entirely. So it feels like a more secure system.
Have firmware people considered to not write bugs?
Yeah,
that's
been mathematically proven to be impossible.
The external watchdog also gives you a power cycle, where an internal watchdog may give you a soft reset. And so it's a different start state.
Yeah, okay.
Yeah, but don't internal watchdogs sometimes like pull on an external pin and then you can do a reset yourself?
Yes, there are a huge variety of internal ones.
Yeah, okay.
Most of the Cortex, though, is a soft restart, which I have to admit I don't really like. I wish it would do the external pin thing because a soft restart doesn't solve all the problems.
Right.
Yeah, okay.
But an internal one is cheaper. It's a lot easier for the software engineers to deal with.
Most of the time, that's fine.
And yeah, it's mostly fine. If you use an external one, then you do all your development without it. Because if you want to JTAG that puppy, you can't have an external. You end up with the jumper to turn it on and off.
I was gonna say, right, and then someone forgets to put it on.
Right.
Or the jumper vibrates off. And you're like, oh boy.
Or you forget to disable it and then wonder why your processor keeps resetting because you haven't written the code to toggle the pin.
But I mean, this does also bring up how do you treat a watchdog? And I was talking to someone today about watchdogs, and they were saying about timer interrupts and watchdogs. And I was like, that's a really, really bad idea. And I wasn't sure if the person I was talking to understood that that is a really, really bad idea, or whether he was trying to be clever.
Because
So the goal of a watchdog is to make sure your processor is doing what it should be. If you have a timer interrupt that kicks or pets, depending on which generation you're in, your watchdog every 60 hertz or 60 nanoseconds or whatever you choose for your timer, then it doesn't matter if your software is wedged. As that only tells you that this high priority interrupt is happening. It doesn't
because an interrupt handler always is going to run unless things are totally hosed.
Yeah, unless you're
gotcha.
unless you're hosed in an interrupt. And so you don't want to put your watchdog interactions in an interrupt. What you really want to do is put your watchdog interactions in the lowest priority thing you're doing, like your while loop. So that, if that isn't happening because your interrupts are wedged or because you have some other thing you're waiting on, a semaphore or whatever, then you reset because the lowest priority thing has to be the thing that's going. If you expect a stable system.
Yeah, there's lots of ways to make watchdogs completely useless.
There really are.
I think Jack Gansel wrote a good article on watchdogs and sort of where to put it in the code. So
starting a sentence with Jack Gansel wrote a good blank is usually true.
Yeah. But I think he I guess said what you said, Alicia. Just where to put it in the code. Don't put it inside a loop because it may just continue on that loop and never get out of it.
What do you, Stuart? What are you using this for? What are you?
Does it involve
designing?
space?
It does involve space, yes.
Yay!
So as part of the little satellite that I'm building, I'm using a watchdog. So I'm using an external one because I need the ability to, I guess, remove the power. So that's where I'm using it in this instance. But I just wanted to, I guess, discuss the benefits of using either way, external and internal.
So just be sure that when you hook it up, you don't have like when the watchdog fires, have the piece of thing in space re-enter. That'd be bad.
No, there's no propulsion.
Jets
No
on
propulsion.
full.
So
That's right.
I'm just depending on gravity and inertia. So hopefully once it's in orbit, it stays there, and only slowly comes down.
Good. Yeah, that'd be really good.
So there are some externals that don't start watching until the first time you interact with them. And that lets you update the code and lets you have a little more freedom. Less safety, but more freedom. Are you using one of those, or are you using one of the old school, you have to boot within a certain amount of time, or you may be stuck in a Watchdog reset loop?
I'll have to check the data sheet. There's usually an initial timeout period before the Watchdog timer kicks in, and I don't know whether that's hard-coded into that Watchdog or externally settable via Resistor. So I guess read the data sheet. I'll have to figure it out.
Be sure to enable it early.
Yeah.
Do you have like multiple versions of backups up there, like multiple Watchdog type things for a piece of space gear? Or I know that there's usually a lot of redundancies, but I don't know how much there would be on this kind of thing, which is pretty destructive.
We should ask him to tell us about what he's building.
Yes, please do.
Right. Okay, so I'm building a Pocket Cube satellite. So you probably haven't heard of a Pocket Cube. It's pretty small. It's smaller than the Planet Labs Doves. You've had the Planet Labs guys on the show, Alicia, talk about their CubeSats. Now they're 10 centimeters by 10 centimeters by 30 centimeters long. So mine's a lot smaller. It's only 5 centimeters by 5 centimeters by 5 centimeters. So it's pretty small. So there's not a huge amount of room for redundancy and sort of additional systems. So it's a fairly simple beast.
And what's it up there for? Is it doing the same thing of like taking pictures, or is it doing something else?
It's not up there yet. It's sort of I guess the project in progress, but it's going to be a Earth observation satellite. So it's going to take photos from space.
And it's like small enough so you can just throw it out there, or how does it get up there?
Pretty much.
Just throw it really hard from a big mountain.
Exactly. Yeah, or like a CubeSat gun. I don't know.
Would you believe that the Russians have actually deployed satellites from the space station by throwing them?
I do believe that.
Yeah. So for these ones, they're very small. So they actually, at the moment, there's only one way to get into space, and that's on board an Italian satellite. And so the Italian satellite has the little, cannons to shoot out these pocket cubes, and that Italian satellite then goes on board another rocket. And at the moment, the planned rocket is a Russian rocket. So depending on funding is whether I actually get on board that one or not.
Cool.
And this is all a personal project, right?
Yes. It's just, I guess, a very strange hobby. There's not many people out there that are building satellites in their spare time. So it's just, I guess, a project that I'd sort of decided to take upon myself to do. I wanted to, I guess, after listening to your shows and hearing about all this hardware prototyping, I thought, it's something that I can get involved, doing. So I wanted to make my own circuit boards, and I figured a satellite's as good a project as any to start off with.
Awesome.
I would disagree with that.
Did I mention
I'm
I'm going to build an electric vehicle. I just, why not? Just the hardest thing I could possibly think of.
Yeah.
I imagine that at one point you're like, I want to build electronics, and then I want to get as far away from them as I possibly can.
Yeah, maybe. I guess it's a bit ambitious, but I mean, when you sort of engineer it and break it down, it's the skills are out there, and if I guess look at all the code that people have done with Arduinos and other microcontrollers, and you combine with the ham radio guys and the amateur sort of balloon community, they've already written the majority of these bits of code. So you can sort of take bits and pieces from what these guys have developed and sort of just roll it up together just in a different platform. And just so happens that this one is a little tiny 5 centimeter cube that's going to go into space and take photos. Sounds simple, doesn't it?
Yeah. Oh, yeah.
It sounds inspiring. I mean, I could see how, all the personal projects, there's always some bit of drudgery or, just some point where you stop and you think this isn't worth it. But
that's usually when I have to do anything mechanical.
Yeah. But I can see how it's going to space would get you over some of those doldrums. My widget in space, I don't know, it just has a nice motivating factor to it.
Yeah, I mean,
or maybe you just want to get far away from it.
No, I think that even sort of when they talk about space and government, no one sort of has anything bad to say about it. It's it's for the benefit of mankind. Now, fair enough. There are commercial companies that are in it to make money, but generally, when you're engineering something for space, there's always a positive sort of spin on it, unless you're the military.
Right. You're not going to be doing a lot of mining with 5 centimeter cubed or whatever the cubic version is.
But you can do remote sensing, so you can, because they're smaller and cheaper, you can make more of them and spit a whole bunch of them around asteroids to measure it. So that's sort of where my goal is for this, is to eventually produce something that does more than just take low res pictures.
Well, Stuart, thank you for calling in. We appreciate it, and good luck with your project.
That's all right. Thank you very much, and I guess I'll keep listening to the show. It's always entertaining. I think even though there's not a huge technical content every week, there's always something that you can just learn from listening to people talking about their projects and the things that they've learned and their experiences. So it's always good to listen to other people.
We are the online water cooler.
Excellent. That's good. That's good.
Thank you.
Cool. Take it easy.
All right. Thanks, guys.
All right.
Well, that's
I'll get a
cool.
link for that.
I want to build something cool.
Once again, I am made to feel inadequate by our listeners or our guests.
So next on the docket is Jonathan McDonald. His question's
Before
hard.
that, I was thinking. No, I know. Before that too, I was thinking. We need more, we've had good. These have been great questions so far, but I feel like there's not enough hardware versus software contention. You know what I mean? Where should a debounce happen? That's what we should have started with, right?
Yes. If we ever do this call-in show again, we want you listeners to think about all of the times that as a hardware engineer, your software engineer has been wrong about, and as a software engineer, your hardware engineer has just been a jerk about, and call in and tell us about those so that you can start the war. Finally,
I don't want to start a war. I just think that's where the interesting stuff lies. I mean, mostly what I'm really saying here is I have no idea the answer to some of these questions, guys. Here's a question. I used to work with a really good firmware engineer who was just gray hair, old school, wrote everything in assembly, awesome, really fast code dude. However, when we'd be booting up a board that I designed, he would turn to me and he'd say, Chris, there's noise on this board. Do you guys ever say things like that?
Not recently, but yes.
And I'm like, Tom, you mean it's not working right now? He's like, yeah, there's noise on the board. And I'm like, do you have any idea what you're talking about right now? And I mean, he was 30-year, former EE kind of thing. Kind of did. But I'm just wondering, are there things like that you say to the hardware people that the hardware people make funny faces?
Oh, there were so many things that I used to do and say. So I got out of school. I was a software engineer, definitely CS, and I had a lot of signal processing math because I was in this weird major that did engineering, not specific, just general, and so I had a lot of systems. And so I went to HP and got further down into the hardware layer, but I really wasn't a hardware engineer. And I got transferred over to become a real firmware engineer. Really neat team. But it was my first day. They sent me down to test boards in the heater or in the oven.
Oh, yeah, right.
And I didn't know. I mean, I didn't think about hardware enough. And so I set the board on the oven floor and turned it on.
Okay. I mean, I think that's fair if you wouldn't have done it before.
I mean, why didn't he give me standoffs? But yeah,
I think it's on him for not for just assuming. But maybe you should have given your background a little bit more.
But I don't think he listens to your show, so I still don't think he knows what happened that day. And he asked me later, was it something about the board, or did you make a mistake? And I said, oh no, I made a mistake. I don't think there's anything wrong with the board here. But yeah, don't set boards on metal things if they have metal pokey bits out. That was my first electrical lesson.
Yeah, I think the thing that I most commonly irritate double E's with is I have no respect for static.
Oh, yeah.
Or rather, I don't believe
ESD?
it exists. I just, nothing has ever gone wrong on a board because I've done an ESD discharge. And so I just don't believe it happens. So I don't handle them with care.
He's sitting here in socks on a wool rug, surrounded by electronics.
On a winter day with...
I've been fine. I think it's a conspiracy of electrical engineers to sell those little things on your wrist.
That's right. They're just fashion accessories, guys.
They are.
I don't know. I mean, honestly, it's gotten a lot easy. I'm going to get myself in trouble here, but it's gotten a lot better. Like, it used to be really bad with like just when people were using JFETs. There's no diodes anywhere. It's like it's gotten better, but you should care about it a little bit.
The processors are a lot more tolerant to handling than they used to be.
Right. Yeah, and again that's the diodes on every pin kind of thing. They're super. They can take a lot of crap. So. Yeah, I bet. I was thinking of what I say to firmware people that pisses them off. I just ask them to recompile. I think that usually gets them going pretty good. Just do it again.
I think it's the insistence. Usually the thing that gets me is the insistence that it's a software problem, and probably conversely, the thing that gets electrical engineers is it's like my first instinct is, well, there's something wrong with the hardware. That usually there isn't.
I think it's good to just keep a tally. That keeps people in line, right? You have a little tally on the wall. Once it gets past maybe 75% towards one person or another, then you have to buy lunch. I don't know. That's how you keep a team together.
Buying lunch really changed my career. That when I started, having lunch with the double E's, just being able to talk to them and say, come by. Maybe I didn't hook up the O-scope in the right spot and you have a test point I didn't notice. And they taught me so much. Yeah. And it stopped becoming a throw it over the fence sort of problem and started becoming a team sport. And I feel like I sort of grew up where it really isn't, it doesn't matter who's wrong. It just matters that we ship.
Except,
yeah, that's right.
Except that they're wrong.
Well, but let's be honest. Like, there shouldn't be that much tension because it's really firmware and electrical people against the mechanical people. Let's be honest, right?
Mostly you guys. We don't care so much.
That's true. That's true. Yeah.
You can fit software in anything.
That's right. Yeah. Well, that's good though. I mean, these are things that we need to work out as a community. This is where the crossover happens. This is when George Jetson and Fred Flintstone are figuring their stuff out, right?
Yeah.
Who's who? And never mind. I don't want to know.
Yeah. Okay.
Yeah. Next caller. We still have two more to get through.
Hello.
Hey, welcome. What's your name? Where are you from?
Jonathan McDonald from Newcastle, Australia.
Seriously, another one?
Really?
That's 4 now.
What is happening?
Man, what is going on here? I swear you'd think that Silicon Valley was in Australia.
It's a conspiracy of Australians.
It's all that Dave's fault. Hey, Jonathan, welcome. I hold nothing against Australians. It's just the 4 in a row. Come on, that's a statistical anomaly, right?
Must be Dave's influence.
I guess so. That's great, though. I mean, do you find that there's a good community where you are?
There's the local TAFE, a couple of people I work with. That's about it.
You said Newcastle? Where's that?
Just above where Dave lives in Sydney.
Oh, okay. Okay, cool. Huh. I guess that's pretty spread out. Sydney's pretty spread out. I mean, there's a lot of people in Sydney, but yeah, that's crazy. So what's going on? What is your question?
I was wondering how I'd get starting with learning a proper programming language. At the moment, I program PIC micros using Flowcode, and was just hoping to.
Can you explain what that is? I don't know what Flowcode is.
Yeah, neither do I.
Okay, it's just a graphical. I guess you'd drop boxes that generates C code. So you drop like an if statement or a go-to statement or output to this pin. Input from this pin, you can input an analog voltage or to an 8-bit value in a register, I guess. And then it generates C code, which then compiles to a hex file then.
And what is the application that it's used for?
Just writing programs for micros. I think you can use AVRs as well as PICs.
Oh, well, I mean, like, are you using it for, like, industrial or, like, for scientific measurement stuff? Or what's the end result?
Industrial. It's...
Industrial.
Yeah, it virtually takes the place of an old PLC we used to use at work.
Yeah. Right.
We use it to automate ladder systems on mining equipment. So you've got large mining equipment, and there's an automated ladder that'll fold out in front of the machine. So I write the software for that.
Huh. Why does a ladder fold out? Sorry.
No, actually, you're right. The mining equipment is far more interesting than the programming language. Go ahead.
No, that's I mean, I've used it to control a few lighting towers, to manage battery voltages and just cut lights out if the voltage is too low. They're like an LED lighting tower. Solar trailers used for radio repeaters. So I don't know, I guess it just seems like a really basic programming language to be using when there's, I guess, better stuff out there. And I was wondering what books were available or online courses.
Well, that was sort of my first question for you, was what's the motivation to move beyond that?
Yeah. It sounds effective, to be honest. It sounds like a LabVIEW style kind of graphical stuff, right?
Yeah.
More like CubeMX, that it starts out graphical and then it goes to C.
Yeah, true.
Yeah, I don't have any problem using it. I was just wondering what other people are using and what communities out there, and possibly learning C a bit better. I mean, we have to dive into C to fix flow code sometimes. There might be a bug in there where it doesn't set the oscillator correctly in the microcontroller, so you have to insert a small bit of C code in there. But
that was my question, was how often do you read what it generates?
Not a lot.
Fair enough.
As little as possible, probably.
Yeah.
Yeah, I imagine it doesn't generate pretty things.
No.
Are you looking to do this for work, or is this more for your interest as well?
Both.
Okay. So I would highly suggest that you don't do it for work to start with.
Yes, definitely.
Yeah. I mean, it seems like, especially if you already have a flow going, that if you try and, like, I would just go, I know myself, and I would just go right back to the other thing and be like, I need this to work right now, click, done, whatever. And that's why these kind of in-between things exist anyways. That's why flow code exists. That's why LabVIEW exists, because it's like you just want it right now. So, yeah.
What's your background? Is it EE?
No, I've done a Cert 3 in electronics, just in the TAFE system here. So that's... I did a small microcontrollers course where we used assembly language to run a program on a computer to output an 8-bit value through the parallel port.
Cool.
So not a lot of experience.
But plenty to get started. You don't have anything to be afraid of. You've already done the worst possible thing with the microcontroller and the assembly. Even if it was small there, other things will be easier and probably more fun once you get to a higher level language.
I think that you already understand, too. Like, I think one big piece of jumping into micros as well is just understanding even what you can do. And it seems like that piece you already have under your belt as well. You know that you can take analog measurements, digital measurements, control things, time things, whatever you want to do there.
Yep.
And so you already get the broad picture stuff, and now it's down to, well, how does this stuff differ? How can I, what kind of code do I need to write? How, is there a structure I can match and play around with, kind of thing?
One thing I would like to implement in code is an astronomical clock. So you input the GPS coordinates into code, using a real-time clock to work out when the sun's going to come over the horizon and when it's going to set. Have you heard of anything like that?
Yes. In fact, I implemented that for something a few months back.
Yep.
For me, actually.
Yeah. So that's pretty straightforward.
Okay. Just a formula?
Yeah, it is actually. I think there were some corrections and things, but it was not that, you have to do a little bit of math and stuff like that. But
since we moved to the beach, I wanted to be able to know when sunset was every day, so that we went down to the beach to see the sunset. It was important enough to demand that he write code for me, despite the fact that I could do this myself.
This is like the first worldiest problem of all time.
Well, if it makes you feel any better, I didn't finish. So. I got it to work once.
I was too busy shining my first edition books and
I got it to work once, and then I stopped working on it. So.
Yeah.
Well, and I needed not only sunset, but like an hour before sunset, so we had time to walk down there. it was it was so first worldy. 0th world, I think.
Yep. Well, I think that's good to have, Jonathan. That's good to have project in mind as well, right? That's another huge piece, is having something to work towards, because honestly, so like I said, you already have a lot of this understanding of what systems can do, right? So you already have some project ideas, hopefully, and then the rest is just finding community online. And C obviously has a bunch. Arduino has a bunch. You could go jump into a lot of other. You could even go crazy if you wanted to. And I'm sure Chris and Alicia will like this one. You could go buy a Tesla board and you could program your micro in JavaScript if you really wanted to make some embedded people angry.
Sorry, you blanked out there, Chris. I didn't hear any of that.
I think you blacked out, actually. You just couldn't handle that statement that people are doing that, which is crazy, but it happens. And, so
people do all kinds of things.
They do all kinds of things. Do you think that, Jonathan, do you want to stay in the embedded realm as well? Is that something that you want to, that you're going to keep these kind of things, or do you want to learn languages that might go higher level?
I'd like Python or something? No, I'd like to stay low level if I can, with C maybe, or something like that.
A good stepping stone would be Arduino, because that's basically C, C++. Maybe you shaking your head at me.
Oh no, I was agreeing, shaking. Sorry, an RTC real-time clock. You can get a little module from a number of places, even in Australia, and a little Arduino board, and maybe a little LED that lights up to tell you which astronomical phenomenon you're interested in, whether it's sunset or sunrise, blue or green or whatever. Yeah, this is a weekend project, because 75% of the code that you're going to look for, you're going to type in, you're going to search on Google, and it's going to be there for you. And your goal is to figure out how to put it together, and it's not going to be very hard.
Yep, excellent.
Top down is very, very important. Get that dopamine hit, man.
Yeah.
Well, that's one of the things you've already got with the Flow program
Flow
you've been doing. You already kind of know how to lay it out. You search, you do this and then this. It's people who try to get 5 things to go on at the same time and don't understand. No, you do have to do one thing at a time, because the processor isn't smart enough.
Unless you jump to FPGAs right away. Come on, you can go right to FPGAs. Talk about a learning curve. I wouldn't suggest doing that, by the way.
No. I did have one other question about hardware. I want to intercept a 10-volt signal, 0 to 10-volt signal, reinterpret that, and then output it to a 0 to 10-volt signal through the microcontroller. I was originally thinking maybe just a voltage divider coming into the micro and then an R2R ladder leaving the micro, but I don't know is there off-the-shelf solutions for that, or I can... I use KiCad at the moment to design boards, so it wouldn't be a problem throwing half a dozen resistors down on the board.
Yeah, what kind of resolution? You say R2R ladder on the output, and I usually just question the resolution you need. So that would be the main thing there.
It's for a throttle pedal, so I think 8 bits would be fine for that. But I don't know. What are your thoughts?
I don't know anything about throttle pedals. It sounds like that's a lot of steps for physical thing, right? So that's 255 steps, right?
Yes.
So that would be that's quite a bit. You can get a lot, especially if you're using your foot. You might have more sensitivity with like tactile hand stuff, but with a foot, you're probably not going to feel that as much. So yeah, I think that would probably do it. But you could just as easily, if you had a DAC output on a, so if you're using like an Arduino, you probably wouldn't be using, there's not a DAC on a Atmega 328, but you could upgrade to a Mega, Arduino Mega, and they have DAC outputs, or you can just set up an RC filter and then do a PWM signal. I don't know if you have ever done that kind of thing before?
Never done that, no.
Okay. So basically the idea is you have a PWM signal that just kind of varies from 0 to 100%, basically chopping up a standard clock signal. And then you put it through an RC filter, and doing that very simple thing, just a resistor capacitor, basically translates it back into a analog signal. And you can get into the filtering if you want to. But then, basically, if you want, you put an op amp on board, get a multiplier, multiply by 4 type thing.
Yep.
Gain of 4, and so you output maybe 0 to 2.5, and then scale it by 4, and you're ready to go.
Yep.
Might be harder than I'm saying there, but
Shouldn't there be a
That's
MOSFET
right.
in here?
where
Some sort of transistor to scale
On
it
the
up?
PWM.
Yeah.
After the RC filter.
no,
Or the
yeah. So
op-amp
like if
will
you
take
have
care
just
of
a
that.
Well, your processor may
Oh, he
not
said he
have...
had an op-amp.
Oh, okay, because your processor might not have enough current to drive things directly, but with an op-amp, you should be good. Sorry, I missed that.
that's so if it's going through an RC to just an op-amp input, there'd be very, very high input impedance, so there'd be no real current flow going. I mean, there'd be a little bits,
Yeah.
but it should be able to drive that no problem. So
Excellent. What about the stability of the voltage coming into the micro? Do you need to put a reference on there, or can you use a Zener on one of the other pins to sort of do some maths against that?
you can test that out. I mean, in terms of how accurate you want it to actually be.
Yep.
Again, I think you'll probably be okay. Like with throttle type thing, it probably, as long as it's consistent over time, then you can always scale it in the firmware.
Yep.
Voltage
If there's
dividers.
but the actual getting 10 volts down to a 5 volt input, I would probably take it down to 2.5 and then get lower scale or whatever the scale is on the input to
Yeah.
Arduino. I don't even know.
What I was worried about was if the micro is if one board's getting 4.5 volts into the micro and the next board's getting 5.5, that could affect the input voltage. Both of the boards are both getting 5 volts on the analog pin, but they're both reading different values in software.
Just because of accuracy of the internal reference?
Yeah.
Yeah, I mean, I actually don't know what the spec on that thing is, but I mean, it depends on what steps you're looking for.
Yes.
So if we take, let me find my calculator app here. If we take 10 volts divided by 255, so that's a step of 40 millivolts, which a
Yep.
lot of references should be fine with. I mean, so even a pretty bad reference should be okay there.
Yeah.
It's almost
When I-
0.05%. Well, it gets 5% reference tolerance.
Yeah, when I have done it in the past, I've upped that to 0 to 50 volt range, so that would become a 400 millivolt accuracy. It's just something I was thinking about the other day, thinking of pushing
Gotcha.
out all this hardware.
I would be probably pretty cognizant of the if you're doing a divider as well, just make sure you have high quality resistors as well. That's important. 0.1% are cheap. 0.01% are not as cheap, but you can do a lot with it. So
Why am I using 5%?
Because they're real cheap.
yes.
The application that I previously used that in was the lighting tower that I was talking about. It's got some work lights on it, and I didn't want to kill the battery bank in that, so the work lights cut out if the battery bank drops below 11 volts, I think, or 10.8 volts.
All right. So any other thoughts or?
Well, I feel like, Chris Gamble, you should probably mention that you have some method to teach people software. I have this guest coming on, and he says he's from Constructural Electronics.
Which I hear you're associated with.
And so maybe you should
yes.
mention the whole...
I should
Should
mention
you
that
want
Eric
to learn
will be
software?
will be on embedded.fm next
No,
week.
no.
No. We teach C. Yeah, I mean using STM32 parts and stuff like that, using pretty standard tool chains. But we also do Arduino stuff. So yeah, we teach all those things. Thank you for making me be self-promotional here. That's good. I forget to do that sometimes.
It's not a plug if you demand somebody else do it. Yeah.
Right. Yeah. No. That's. But I'm not sure. So like someone like Jonathan, I would probably point them to like an Arduino tutorial where it's just a bunch of projects to start with. That's a good place to start, because especially if especially people that don't have projects in mind, where you're handed a project, especially if you find a project you're interested in. That's just to get going. It's all about momentum. So, and that's when Dan and Michael were on the show, we talked about a lot of that stuff. Just the momentum is really important. I probably wouldn't promote myself on that in this case. But
if
eventually.
you're doing it for work, then maybe you do want a formal thing so that boxes can be checked at work. And
Yeah,
on
true.
the side, you can do more fun things.
True.
Yeah.
Yeah. Well, that's and what is this is for mining equipment, you said, right?
Yeah, for anything really. Automotive, I guess, would be the way to describe it.
Okay. Oh, cool. Okay. Yeah, that sounds like you have a lot of really good challenges there. So that's,
Australia's really big, and they have really industrial things, farming,
Especially
equipment, and mining and
Fences.
fences.
The rabbit-proof fence.
The rabbit-proof fence that Steve
that
Dalton
was
worked on. We didn't really
Steve,
talk
right.
about it. Yeah.
right. Episode 63 of Embedded FM. Well, Jonathan, thank you for calling in. That was a good set of questions there.
Thank you.
Thanks, Jonathan.
Thank you.
All right.
Cool.
We are down to one left.
Yeah, except he's not Australian, so I don't think we should talk to him.
We should ask him to talk in an Australian accent. What do you think?
I believe he's already been asked in the green room that is Skype that he has to have an Australian accent.
Okay, well let's get it going then. Here we go.
So this is going to be Christopher Sveck, and he's actually been on our show too. So this is cheating for us.
Nah.
How you guys doing?
Good.
Good, how you doing?
Welcome
Good.
back. You're, past guest of Embedded FM. Another one. So
That's right.
why didn't you tell us from memory which show you're on? Can he do it?
The number?
Can he do it? Yeah.
No,
No looking it up, man.
no, I cannot remember the number.
Oh.
I couldn't even tell you the title.
Number
they were both-
78, Happy Cows.
Oh, I remember that one. Yeah, that was good.
Yeah.
So, what part of Australia are you from?
That's right. Yeah.
The Sydney. That's a city in Australia, right? That's right.
Good guess.
Yes, and it's currently
Yeah.
summer here. I think. Right.
Yes, that's right. Yes.
That's a good guess.
Excellent. Did you plan
Excellent
this?
call quality for getting all the way over there. Yeah.
Oh yeah. So how bad was that? Pretty bad. The delay with all them.
No, it's good old undersea cables, man. Remember, I talk to an Aussie every week, so yeah, it works.
Yeah, I figured you guys had something special set up as opposed to just regular old Skype. But
So
Where
what
are
is
you
your,
actually from?
Oh yeah, that's a good question.
I'm actually from. I grew up in Anchorage, Alaska.
Really? Oh
yeah,
wow.
yeah, I did. I lived there till I went to college. I ended up a few other
It's like
places.
reverse Australia.
It is reverse Australia. Some people think it's part of Canada. People think it's part of Russia. But yeah,
Cool. And your question?
Where are you now?
Oh,
I
sorry.
am. That's okay. I'm in Raleigh, near Raleigh, North Carolina.
Cool. So what kind of question do you have for us?
I've got it up here. I'm going to read it so I actually kind of get it right. So the gist is, what unmet needs exist in the embedded development world? Or put another way, what embedded development product or service, like hardware or software, that you would pay money for? What product like that doesn't exist, or what product like that would you like a better or a different version of? And the thinking is that, I use a bunch of different products all day, and some of them I wish were a lot better. I could name names, but I'm not sure if I want to offend companies that I rely on. But anyway, some of them
Chris, it's time to renew your subscription to our service, and your price went up 5,000% because we heard what you said.
exactly. Or my employer gets mad at me along the way or something. But anyway, I'm just wondering what kind of stuff would you all want that just isn't out there, or that's out there but just isn't good enough, or lacks a lot of features.
I was hoping for a micro that could run JavaScript. Is that?
Coming. And actually,
something?
there are a couple.
I know. I made fun of him too. Don't
He's
worry.
just poking.
Oh,
I think
he's trying
was
to
he
make us
bait?
mad.
Yeah.
Oh,
was
I
bait.
see. Yeah, that was just baiting.
Chris,
wasn't
really?
it?
I know. I've come on. I listen to your show. I get to hear it every time. Like I know it is coming too. Like I can hear it. I'm like, oh, they didn't. Oh no, they didn't.
So
I'll let you guys start. I have no idea.
Well, I think you know the obvious answers, Chris. So, skipping past those is a little difficult. I mean, I don't think the development tools on the software side are good. And
you mean like IDEs?
IDEs, compilers, debuggers, I think that's all probably 10 or 15 years behind where desktop targeting tools are. And I think a lot of that is because...
I was going to say, sorry, that's the big tool that I use every day that I'm like, why is this 15 years behind anything else?
Partially because there's no reason for it not to be.
Yeah.
Well, the embedded community is so much smaller. And so we don't have as much money to pay to get the good compilers. And we have such diversity of needs with our compilers. I mean, sure, Cortex, there are a lot of them now. But a Cortex compiler is going to be way different than on an STM versus a TI with Bluetooth in it. So we need all these new compilers all the time. We're a small group, and we really don't want to pay for anything.
Well, and all the resources at those companies making those tools that we have elected not to mention, I think a lot of the resources go to targeting those new chips as they come out. It's more time spent. Okay, there's a new TI chip. I've got to figure out how to optimize for that. Or there's a new ST chip. Got to optimize for that. And so if you're a small company, which most of those places are,
they really are,
there's not a lot of time to go back and edit the user-facing stuff.
Sure. No, I totally. I didn't mean to sidetrack my own question by saying why these tools are like that. They are for very, very good reason. But I'm just wondering what else is out there that you all have run into that, someone like me or someone like, who wanted to actually like develop some products like this might cook up and actually make a living at.
Are you looking to do this yourself? Is that the idea? Are you looking, you want to build something?
It's always been sort of like, hey, someday, or, what kind of a side project might turn to like a little revenue on the side kind of a thing. Note to anyone from my employer who's listening, I'm not looking to leave the job. I'm good to go. Thanks. But
come on, man, be bold.
No, I'm all right. I've got a good gig. No, just just scratch your own itch and make a little extra income on the side. So just curious what you all see as a need.
Well, if we look around and not worry too much about like compilers or RTOSes or even graphics libraries, which I think could all be argued maybe what you're looking for as an answer, and instead look at what have some of the people around us done that have made a reasonable difference. Osh Park comes to mind. Lane wanted boards, and he wanted it not to be so hard. And so he wrote some software, and now suddenly we all get purple boards because it is the easiest way to get a small number of boards. Or you look at Bob Cogshaw at Small Batch Assembly, and he wanted that really awesome assembly tool, but he also wanted his boards assembled. And so he figured out how to make a small business around the problem he had. And you look at Tindy and all of the things people are building there, which are mostly solving their problems and then leaking that solution out to other people for a little bit of profit. And I like that method. Instead of like, what problem can I solve? Everybody should have it. What problem do I have? And how much does it annoy me? And can I solve it in a way that like pays for itself?
Yeah, my problem is that I look at the problems that I have are things like my entire development environment. I think, why is this so bad? To go start a huge company to fix that kind of a problem.
It's hard to even start a company to do that because it's not clear you make your money, right?
Yeah, absolutely.
I do see some of that moving to open source. I think that compilers and things, Clang is going to start targeting more chips, and people are going to get interested in that, and perhaps the problem on that side goes away.
You're on an electronics podcast. Can you explain what Clang is?
It's a new compiler, open source compiler. I think Apple's had a lot to do with it.
Cool.
Sort of a competitor to GCC.
It's a more modern GCC, competitor.
Oh, cool.
But it does some interesting things that allow it to be more flexible in the back end generating code. But But people are getting excited about that and ARM, and I'd like to see some movement there. But I just can't see building a company around tools, because there's so much stuff out there already, and I don't know that people are really using a lot of it. You look at the Greenhill stuff with all the advanced trace tools for debugging, or static analysis tools. All that stuff is there.
Wow, is it expensive, though?
And it's super, super expensive, and I'm not sure how much value add is really there.
I think it's that's a marketing problem more than a technical problem. Because how do you manage to sell the 15 licenses you need to employ an engineer for a year?
Wait, are you saying that at that price or any price?
Well, okay, it's a market problem. Either you sell...
You have 1,000 customers.
Yeah. And so
Maybe.
if they all buy at $1,000, well, then that's actually just fine.
For 3 engineers, maybe 4
2-person shops, yeah.
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 But more likely, you're going to get 100 of them to buy for $10,000. But now you have to go out and explain why $10,000 is worth it. And so in addition to your engineer, you also have a marketing person to go out there and do that. And then because they cost $10,000, as an engineer, you're not just developing the thing you wanted. You have to do all the DRM crap, which probably for many engineers means hiring a different person, because you just can't live with yourself afterwards.
All right, so those are things we can't do. I'm going to pie in the sky about things. I think you really kind of wanted more broad answers of the classes of things. So things I would like to see. I would like to see something I can stick on buses, I2C, SPI, whatever, and tell me something's wrong. So something's pulled high when it shouldn't be, or
like an oscilloscope.
No, I want it to tell me. I don't want to have to look at it.
So you want like a magical debug?
Yeah, debug this bus.
All right.
I thought at first when you said bus, I was imagining an actual like bus. I don't know why my brain went there.
Yellow.
I was thinking
magical
like a big
bus
yellow
with wheels
cheeser.
on the bus go round and round.
Right.
That too.
Keanu Reeves hops on and tell you if Sandra Bullock is on the bus, kind of a thing. That kind of a bus.
Dude, pull-ups.
So you mean like those tools that go on your car and will sniff the CAN bus and tell you that your engine is
I want somebody to say this has
ODB2.
This has timing problems, or you have a capacitance issue, so you've got your rise time is screwed up, or you've got excessive ringing, because
or you're getting lots of collisions.
Because I want to put double E's out of business.
Cool. No, I like this. This is good. This is good stuff for our podcast. That's good.
Okay. So in the
I think I'm going to go start working on this, because it doesn't seem that hard.
It seems like a really good idea. I like it.
Why do we keep these guys around? Yeah, no, I think, but any tool where you're developing something like that, it's always in, like I said at the beginning of the show, you guys make the money in the corner cases, right?
Right.
You can have something that might, and there are things that are out there that do some of these type of things. I mean, even, scopes with protocol analyzers, that kind of thing. However, it's often knowing that you have the problem and then being able to apply it quickly, and then hoping it's not a corner case.
Yeah, sure.
Right. Those are all like, but you're right. I mean, like, that is totally buildable for a lot of that stuff. So
can you add a mode for me? I wanted to connect to 2 things, and it should tell me if their impedances matches, and if they don't match, it should give me a very clear explanation on what I should do to make them match. I hate it when the impedances don't match.
You mean like for like a signal line, or like what?
Yeah, for signal lines.
Okay.
It would be the same sort of, because I'm thinking all of the times that I've had to go to a double E and say, I give up.
Right. Okay.
And there should be you should put it on power and ground, and it should say how many capacitors you need and where they should be on the board.
Where they should be on the board. You should take a picture of the board, and then it should generate a schematic.
Reality.
Near the chips is the answer.
But in all seriousness, I do think
but
hardware.
But you guys are asking, but this is embedded people wondering, hoping for hardware tools, and as a hardware person, I'd hope for embedded tools. But it's more of an accessibility thing, right? You're not gonna like. So if I I mean, something like Embed would be something that probably someone like me would ask for, right? Where it's like, oh, I just want the library so I can just get this thing running, and then make it easy to customize if I really need to, but just twiddling a couple things. That's... But it's not... Chris's question was about embedded tools for embedded people, right? And it's like anytime you have a pro tool, I don't think you can't. I mean, like without... Like there's a reason that these pro tools exist, and that they're crappy interfaces because there's so few people working on them, but yeah, that's the market problem.
But there's also, strangely, a lot of people who are making a living on open source tools. And so you don't have to invent the wheel. You could just make the wheel better. And if you can figure out how to get paid for that, that's sort of exciting. Whether it's doing support for OpenOCD and all of its lovely tool chain, or working with a company who wants to use OpenOCD, and so you can make it better.
Do people make money off OpenOCD?
Not yet.
Yeah.
Yeah. See,
I do wonder.
I've used the IAR toolchain, and I've used all the free OpenOCD GCC toolchains, and I looked at the GCC OpenOCD. You throw an ST-Link that costs $10 in the toolchain, and you got your hardware, you got your software, and I look at that and I think no one is making any money. I mean, ST is making money because they're selling the chips that you use to program with the ST-Link $10 piece of hardware, but no, I don't see anyone else making money in that chain. So that's part of what generates this question.
Well, it's kind of what happens on desktop, right? I mean, Apple doesn't make money off their IDE, and yet it's generally considered to be pretty good.
Mm-hmm.
So it's almost like you need one of the chip manufacturers to say, you know what, we're going to make the premier embedded IDE, and it's only going to work with our chips.
And that happened with Code Composer for TI, and now look where we are.
Oh, it's
yeah,
not necessarily a bad thing.
I've worked for chip companies, several of them, and I've been through a couple of those acquisition sort of thing too. Those are tough.
Yeah, because it is a never-ending problem.
I want to throw the question back at you.
Yeah, I think you have stuff in your brain, Chris. Come
on. The protocol. So here's the thing. So like the easiest thing I've thought of is, I'm looking at UARTs all day long. I've got usually hardware UARTs, USB to UART, something. It's a UART in most of the systems that I work on, and so it's sort of annoying to go behind my computer and plug in 3 or 4 USB cables to all these things. And so I think, I should make Wi-Fi or BLE or whatever, some sort of a wireless UART. And I Google for it, and there's actually, I figured there should be like 10 of these out there because they shouldn't be that hard to create and shouldn't be that expensive for the hardware, but I don't see any of them. And that makes me think, well, there's probably no money. It's not worth my time.
No, wait a minute. I mean, the ESP8266
Sorry, I
is a UART to Wi-Fi, and there are a ton of BLE to UART. Maybe I don't understand what you mean. I mean,
I think he means for debugging, having kind of a hub.
Yeah, like streaming data back.
For debugging, streaming back. Yeah, that's exactly it.
You would use a Wi-Fi thing for streaming data?
He doesn't want to lean down behind his desk all the time. Right?
Is that right? Like a $5 USB hub?
That is part of it. I mean, okay, so I work for a company that makes robots, and my robots move a lot, and so cabling them up to stuff is tough. And
yes.
Okay, that's a better question.
Yeah. Sorry, I didn't explain that well at all, Chris. Chris White surprised me with the flipping the question on me. So you have all Aussies on here and then all Chris's. I like it. You guys really have a kind of a
That's true. I can just say Chris to anybody and it could be all of you.
It is.
So you, I actually have had this problem and solved it I had a serial port output logging system and then wanted to put that to a thumb drive so that I could have my, not a robot, but a toy that wandered around, and be able to log the responses to the thumb drive, and then I could do my data analysis on the thumb drive. And at the time, that was a huge pain in the neck, and now exist plenty of people already doing that as a tiny little addition to your system. But you just want to do that as a Wi-Fi thing. This doesn't seem hard.
It doesn't seem hard. I'm surprised. Maybe I just don't know how to use Google very well. But and I don't just want to do logging. I want to do bidirectional.
I mean, I would worry about the actual connection for like the streaming, because if you lose a packet or two, you're going to be losing that. But why not just do it through like a BeagleBone and then have a bunch of serial outputs on the BeagleBone? And then have a Wi-Fi chip to the BeagleBone, and then, like Alicia said, like logging on that, and then you could just go check it after the fact if you needed to.
Yeah, so the way that I actually have solved this is I use either Raspberry Pi, or I've never used a BeagleBone in particular, but I've used Raspberry Pi, same kind of thing. It has Wi-Fi. You know, smash it on top of whatever device you're trying to test with. You use the UARTs under the hood there. But those things, they're not exactly low power. They change the system enough, and they're not physically very small, which if you're using the sorts of robots and systems that I am, then they need to be like smaller is better. You don't want to add to the physical footprint very much.
You need an ESP8266. It will do exactly what you want. You program a little bit of code in there. They're super small. They're low power. It will.
You do it over TCP, and you're not going to worry about losing packets as long as you're not doing something crazy.
And they've already got like a UART output.
But he wants to, he wants somebody else.
He's
to
not going to build a company off of this, though.
That's a service thing, though, right?
I'd be very happy to, scratch my own itch and actually cook that up. I guess when Chris asked me, "Oh, what's the thing?" You've got to have something in mind that you want. This is the prototypical thing that I think I want this, and I'm also surprised why doesn't it exist? Like I realize that this is not technology that we don't have yet. I haven't seen it packaged in a Adafruit style or stuff that I can buy for $15 or even $50. I just
plug it in and go and.
Yeah, exactly.
The bus pirate slash Wi-Fi.
The Wi-Fi bus pirate.
Yeah.
Yes. Yes.
Yeah, that's a good point.
No, I think there's a lot of opportunity for tools like that, and I think honestly people tend to make them when they need stuff desperately, or they tend to do what you do and all right, we'll put a Raspberry Pi on because
make it work enough,
and then we don't think about it any further. But I bet there's a lot of opportunity for hardware tools that's just going by the wayside because things have moved so quickly in the last couple of years that people haven't even caught up to what you can do for $10.
Yeah.
Well, and I think if you add a software layer on top of it too, so it's even more accessible. So like if you had that's one thing with the bus pirate is not just like, I mean, it is terminal commands, but there's special, they have their own little terminal, right?
Mm-hmm.
But I mean, it's accessible for people maybe outside of, just running from a command line. If you can layer software on top that makes it look good on the client side too, where it's like, oh, okay, this is the tool, right? So now it's not an ESP8266, it's built with an ESP2, one of those things, and it outputs serial, but there's like a software interface. Then it becomes like a more product type thing, right? That's kind of the product design side of it.
Yeah, I mean, when you say that, it reminds me of the Salia, which is, a logic analyzer. That,
right, exactly.
Shipping bits across USB is not exactly novel, but their software looks good, and it's actually reasonably usable.
Yeah, I love their stuff. That's good.
So I bet we get messages saying this exists, and they tell us where to go to get the Wi-Fi bus pirate. But I think the important thing from that is not to give up hope. It's, I had a good idea, somebody else had one, and to look at how they did it. Because the next time you get irritated and think, if only I had this, and you don't find it online, that may be the time you say, oh, this is what I should be building.
Mm-hmm.
And between now and then, keep looking around to see what the path is.
I would say don't be afraid to tweet the question too. Don't be like, oh, well, if I tweet about it, then someone else will take the idea. Most people, no one's, even people listening here, like maybe one person would consider it and look it up and say, oh, I'd like to do that idea and take that idea. It's like, who cares? Like if you want a thing like that and you ask around on Twitter or elsewhere, I think that's good. Put it out there.
Yeah,
and then you're going to find out for sure if the tool actually exists in the world. And if not, you might even have some collaborators that are like, hey, I'd be interested in working on that with you.
I'm assuming you all will take some sort of a cut of the IP from this phone call here, right?
I don't think you're going to make much money on this
cheap.
one, but
no.
yeah.
Yeah.
You can make a honorary donation to both Embedded FM and the Amp Hour after the fact. How about that?
Nice.
Yeah.
Although we know that Embedded FM does not take any sponsorship at this time.
That's true. I did hear that.
If you heard any, it was not put there by them, and they received no revenue.
Yeah. I heard that statement and I was like, I bet their CPA wrote that. Or their lawyer.
I actually wondered why they wrote. Why did you write?
Yeah, why? What's up with that?
I was listening to a couple other podcasts. In fact, it was 99% Invisible. And he had a statement at the end like that. And I liked it. And then I was listening, I don't know, I got onto, somebody said something about Stitcher and how it cut up one of our interviews to put ads in. And I'm like, that sucks. People should know that is not us.
Yes, I don't edit things that way.
Yeah.
I
should know not to use Stitcher.
I wondered if it was a Stitcher. You should all be using Overkill. That's what you should be using.
But there's a lot of podcast aggregators that do weird things, so it's probably a good thing to just remind people that what they're hearing is possibly not what we intended.
So what you're saying is I should start my own podcast aggregator that adds, and removes hosts saying there shouldn't be any ads. Is that what you're saying? That's what I'm hearing.
I'm hearing that podcast tools are a big market, so yeah.
Possibly bigger than the embedded tools market.
Yeah.
It's true. There's more people hopefully listening to podcasts than worrying about
paying for them.
Yeah.
That's true.
Is this your day job?
Yeah.
So you guys are going to edit my entire question. This has gone south.
No, this is the show.
This is far north of where we've been.
Yeah.
Well, that's good. Is that just because I'm in North America and not Australia?
Well,
yeah,
north.
that was actually what he meant. We were hoping you didn't notice.
I'll take it.
let me know when you've got the cool IDE done.
Yeah.
Well, it has been good to talk to you.
It's been great. Thank you very much. I appreciate the call-in show from all three of you.
Thank you.
All right. We'll talk to you soon.
All right. Well, that seems like it's a show. I mean,
I don't know. Only an hour and 45 minutes in. Come on.
Do you need me to find some more callers? Because I don't have any more. Sorry.
We're all out of Australians.
Yes. There are only 7 of them there, and Dave was on vacation.
No, I think we're good. That was a lot of great questions. Really good stuff, and hopefully we'll be able to do this kind of thing in the future as well. Dave does go on a lot of vacations, so that happens.
Oh, it was fun.
Yeah.
I was thinking actually maybe next time too we could pull in a mechanical person and really have a knockdown drag out. You know.
I don't know what I'd ask a mechanical person. I mean, all of my mechanical questions involve, can you show me how to do this when I have a pile of parts in my hand?
I'm just thinking of one mechanical person, and never mind. It would not.
So
it would
not,
be
not that person.
It would be a fantastic show, but not that kind of show.
Gotcha.
Well, maybe somebody can suggest a mechanical person who would be a wonderful personality and can answer questions without seeing any of the parts involved.
So tolerances. Why are you so upset about
That's
them?
right. What's with you and your micrometer? What is the deal with vernier calipers are for wimps?
Why can't I put the screw hole underneath the chip? It's a ball grid array. It'll be fine.
Yeah, I have an answer for this. Yeah, I guess I didn't even think about that. You guys don't really ever had to. You never really had to interface with the mechanical people, huh?
I have in the past a lot.
I have, but
Why?
it's usually outside my job.
I was working on. I guess I can say I was working on micro telescopes to adjust beam focus of lasers, and so the entire multidisciplinary thing was. There was a lot of back and forth between software, electronics, and hardware on that kind of thing.
Yeah, I guess if you had a piece of software that was controlling the physical world, like through a motor or whatever, then yeah, for sure that actually that makes a lot of sense.
And we had we had markers and things and feedback, so we had to say, well, you need to put this here so we can see where home is and that kind of stuff.
Well, and I worked with mechanical engineers mostly at Leapfrog making toys, where they would want to put together a switch that cost only 2 pennies. And I would say, that Switch really sucks. Can we have something better? They'd say, well, maybe if we add something, it will cost 2.1 pennies, but that's a lot. And so, yeah, wow.
Right. That could be another interesting crossover too, with like code versus manufacturing people, or I mean, obviously electrical plus manufacturing type thing, like large scale manufacturing. We kind of did that with Jeff a couple weeks ago, talking about that stuff.
That was with the Mighty Ohm show, right? Jeff Geezer?
Mm-hmm. Yeah.
Cool.
What'd you call him? Keezer?
Is that right?
Rhymes with geezer. It's Kaiser.
I have
Kaiser, like the.
I only know him as Mighty Ohm. I'm sorry.
That works too.
Sadly, I am far more into Twitter than I ever thought I would be.
Yeah.
So embarrassing.
Which is where people can find us, which is how we should wrap up the show. What are your respective handles?
I'm at Stony Monster. Don't ask why.
Do you want to spell that?
STONEYMONSTER.
And I'm at Logical Elegance.
Which is also the name of y'all's company, right?
That is our consulting company. We do embedded software consulting. We're busy.
That's right. So people are listening and they get, if they have a challenging problem and can pay well, call up Logical Elegance.
And we'll tell you we're busy.
The phones are open and probably busy, yes. I am Chris_Gamble on Twitter, if people don't know, and the Amp Hours on Twitter, as is Dave, as EV Blog. Guys, thanks for being on the show. It's a lot of fun.
Yeah, this is great.
Thanks for having us. And can I also say thank you to Andre from the Great White North for keeping our Skype green room warm.
Yes, he's quite the character.
Yeah, it was fun.
All right, guys, we'll talk soon.
Thanks, Chris.
Bye.
Bye.
Thank you.